An architect is building a vertical monument. The base of the monument is a rectangular prism. There's a pyramid at the top, so this looks a little bit like the Washington Monument. The measurements are shown below. What is the volume of the monument? So we have this rectangular prism, and then we have this pyramid on top. And so the volume of a rectangular prism is pretty straightforward. It's just the width times, or you could view it as the length times the width times the height. So just the prism, and let me color this prism in blue. So this is just the base right over here. Let's figure out the volume of just the base. So I'll call it the volume of the, well, let's call it B. Volume of the base is going to be equal to the length times the width times the height. So that is 16 times 20 times 85. And well, I could write the units down just so we see it's going to be cubic feet. 16 feet times 20 feet times 85 feet. 85 feet is equal to something feet cubed, or cubic feet, and I could work this out. 16 times 20 is going to be 320, and then I want to multiply that times 85. Multiply that times 85. 5 times 0 is 0. 5 times 2 is 10. 5 times 3 is 15, plus 1 is 16. Now I have to worry about the 8 right over here. Keep a 0 here because it's really 8e. So 8 times 0 is 0. 8 times 2 is 16. 8 times 3 is 24, plus 1 is 25. 25, and then we add them all up. 0 plus 0 is 0. 0 plus 0 is 0. 6 plus 6 is 12. And then 2 plus 5 is 7. And then you bring down the 2. So 27,200. 27,200 cubic feet. That's just the base. That's just the base over here. Now we have to figure out the volume of this pyramid. And I'm not going to prove it here. And actually, I'll maybe prove it in another video. And you need a little bit more sophisticated math to be able to prove it. But it's actually pretty neat what the formula for the volume of a pyramid is. Because it's kind of what you would guess based on if you know the area of a circle. The volume of a pyramid is the length times the width times the height of the pyramid divided by 3. And the reason why I say that's pretty cool is because if you're looking for the area of a triangle, it is the base times the height. And you could view the width or the length as the base of one of the dimensions of the base. It's the base times the height divided by 2. You could view area as kind of a volume in 2 dimensions, and volume is volume in 3 dimensions. 2 dimensions, 3 dimensions. So it seems like that works out. I can't even visualize a pyramid in 4 dimensions, but I'm curious, what would be that hypervolume? What would be the formula for the hypervolume for a pyramid in 4 dimensions? That's something that you can think about after this problem. But with this out of the way, now that we know the formula, and we haven't proven it to ourselves, but it has a certain elegance to it, so we'll just run with it for now. So the volume of the pyramid, this pyramid in particular, we know what the length and the width are. It's the same as the length and the width of the actual base. It's going to be 16 feet times 20 feet. And then we're going to multiply it times the height of the pyramid. Now you have to be careful here. The height of the pyramid is not the length of one of these edges right over here. The height of the pyramid is if you were to go into the middle. Let's say imagine this pyramid is transparent, and if you're at the middle of the top of the base right here, and you went straight to the middle of the top of the pyramid, that is the height. And they gave us that height at 22 feet. So this is from the top of the base. If we were to go straight up, not along this edge, if we were to go straight up to the same height as the top of the pyramid, that is 22 feet. So the height over here is 22 feet. So that gives us, it's going to be 320 times 22. So let me write that down. This is going to be equal to 320 times 22. Just multiply it out. So first I'll use that 2. Maybe I'll do it in blue. So 2 times 0 is 0. 2 times 2 is 4. 2 times 3 is 6. Now I'll worry about this 2. Well, this is really 20, so we have to put a 0 here. 2 times 0 is 0. 2 times 2 is 4. 2 times 3 is 6. And we add them all up. 0, 4. You get a 10, bring out the 1, and 7,000. So the numerator right over here, the numerator, the length times the width times the height is 7,040, but we actually have to divide it by 3. If we just left it this would be the volume of a cube of those dimensions, but we care about a pyramid, so we actually have to divide it by 3. So it's going to be that quantity divided by 3, and it's feet times feet times feet, so it's cubic feet. So it's going to be that divided by 3 cubic feet. That's going to be the volume of the pyramid. Volume of the pyramid. And let's actually figure out what this is. So if I take 3 into, and I could use a calculator, but that wouldn't be as much fun. 3 into 7,040. 3 goes into 7,000 2 times. 2 times 3 is 6. Subtract. 7 minus 6 is 1. Bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. Subtract. You get 1. Bring down the 4. 3 goes into 14 4 times. 4 times 3 is 12. Subtract. Subtract. Bring down the 0. 3 goes into 20 6 times. 6 times 3 is 18. You subtract. You have a remainder 2. We could keep going and have a decimal, or we can just write that the volume of the prism is 2,346 and 2 with the remainder, so 2 and 2/3 and 2/3 feet. And 2/3, if we kept dividing, we would get 0.66666, and we would just keep on repeating forever. So that's the volume of the prism. We already know the volume of the base. The volume of the base is, let me align things. The volume of the base is 27,200 feet cubed. These are both in cubic feet. And then we can add them together. So you're definitely going to have the 2/3 there. You're going to have the 2/3. 6 plus 0 is 6. 4 plus 0 is 4. 3 plus 2 is 5. Put the comma in both of them. 2 plus 7 is 9. And then you just have this 2 over here. So the volume of this entire Washington Monument-like looking thing is 29,546 and 2/3 cubic feet. And we're done.